Okay, so it's important to note that when we have a segment, the perpendicular bisector, we know that a point on the perpendicular bisector is equidistant to the endpoint. So essentially we're saying that the distance from a point here to this point, the distance between points, we know, all right? But now the distance between a point and a line is a little more complicated, because if I have a line, I have a point, you know, what is the distance? Let me get a different color. Is this the distance? Is this the distance? Well, I'm going to explain how it's defined. The distance from a point to a line is the length of the perpendicular segment, which means that neither of these lines is the distance, because neither of these segments are perpendicular to the line. So what would be the distance from point A to this line L here if I find the segment that is perpendicular? So that would make this thing here the distance from the point to the line. Remember, I know how to find the perpendicular segment from a point to a line. Recall the constructions. If you need to review constructions, then right here, review 3-6. But I'll show you again without the right tools. I don't have the tools with me. But to find the distance, or to find this perpendicular segment from B to this line here, I'm going to get a compass. I'm going to put this here, the same distance. Okay. Then from this distance, I'm going to find, again, from here, I guess it doesn't matter, but with the needle here this way, with the needle here the other way. So this point is on the perpendicular line. Should make that the distance. Okay. So now that you know the distance from a point to a line, we can talk about the angle bisector theorem, which is worded a little similar to the perpendicular bisector theorem. The angle bisector theorem states that if a point is on the angle bisector, then it is equidistant from the sides of the angle. So this point right here, because it's on the angle bisector, I know that because of this, it is equidistant to the sides of the angle. So let's say we have angle P. I know this is a really bad drawing. It's not really done to scale because these angles don't look the same. But my if statement would be then, because I'm saying if my point is on the angle bisector, that means that I need to know that QS bisects my angle PQR, and that, remember, the distance it has to be perpendicular, so I need to state, and my two distances, SQ is perpendicular to, SP is perpendicular to QP, to ray QP. So this is perpendicular. So SP is perpendicular to QP, and SR is perpendicular to ray QR. So I know that this is perpendicular. So if I have a point that is on my angle bisector, and it is on a perpendicular segment to the sides, then that would make these congruent. Then PS is congruent to, let's say, RS. Okay, that point is equidistant to the sides of my angle. Remember, the distance from a point to a line is a perpendicular segment, so I need to be shown here that this is perpendicular. Otherwise, this would not be the distance. Okay? And the converse would be the opposite. The converse then would state that if a point in the interior of an angle is equidistant from the sides, so if we have an angle, the same angle, and we have a point, let me write this. So we have angle PQR, and if we have point S, so we have a point that is equidistant. So I have, remember, how do I determine if it's equidistant? Well, it has to be perpendicular to the sides of an angle. Then this point is on my angle bisector. So my if statement is if SP is congruent to SR, and they're perpendicular because it's the distance. So if SP is congruent to SR, and if SP is perpendicular to QP, ray QP, meaning this is perpendicular, and SR is perpendicular to ray QR. I should draw my arrows. Then that means that S is on the angle bisector. So then QS bisects angle PQR. Okay? So it's important. Notice that in the if statements for the angle bisector theorem and its converse, we're given this. Why are we given this perpendicular statement both times? Because remember, that's the definition of the distance. So anytime we're mentioning the distance, equidistant, when dealing with angles, this needs to be implied, that it's perpendicular, because that is the distance from a point to a segment, okay? So that has to be a condition. This perpendicular segment has to be a condition, an if statement, for both the angle bisector theorem and the converse, okay? So let's do an example in which you can use this. So example 3, we have the following. We have angle LNQ that's being bisected. I know this because I have the two congruent angles here. And we have a perpendicular segment. Remember, when you see a perpendicular segment from a line to a point, it means that it's the distance. So essentially we have distance MR and PR. Well, using the angle bisector theorem, I know that MR is equal to PR, which means that 7x equals 2x plus 25. Subtract 2x from both sides. 5x equals 25, which means x equals 5, which would make RM equal to 7 times 5. RM equals 35.